Good morning, students. In the yesterday's class, we discussed about SN1 mechanism, SN2 mechanism, and Wood's reaction. So today I'll explain. I'll continue with the Fittig reaction. So as I told you, Fittig reaction. So here the reaction is same like the Wood's reaction. Only the thing changes here is what? R group. R group is which group here? For Fittig, R group must be a aryl group, means benzene ring. So same reaction, we directly take this one. Aryl halides. Okay, plus 2Na plus this one. Okay, what they will form? HALOALKANEs. Plus 2Na6. Here we are going to use dry ether as a solvent. Means when aryl halides reacts with sodium metal in presence of dry ether, they form biphenyls. So this one is biphenyl. Means two phenyl groups. This one is aryl halide or HALOARENE you may say. So can you say when aryl halides reacts with or treated with sodium metal in presence of dry ether as a solvent forms biphenyls. Okay, so if you take the example here, I'll take example of benzene ring is in the place of X, we may take Cl, chlorobenzene, or benzene chloride, benzene chloride you will say, or chlorobenzene. Plus 2Na plus the benzene ring with the Cl alcohol. Okay, then the product form is so here it is same biphenyl along with what is the byproduct here? With sodium metal, what is the byproduct? 2 moles of NaCl. So here we are using same here. So in the place of aryl halide, when chlorobenzene reacts with sodium metal in presence of the dry ether, forms biphenyls along with NaCl fumarate, fumarate. Reaction is same, but the reagents are different. Understood? This is what? Fittig reaction. 2 marks. This reaction also 2 marks. Fittig reaction is also 2 marks. Next. Next one is Wood's Fittig reaction. Since the name itself says, Woods reaction means we are going to take alkyl halides as the reagents. For fitting, we are going to take aryl halides as the reagent. For Woods fitting, we are going to take two different halides. One is alkyl, another one is aryl. So here, alkyl means RX, that's 2Na. Another one is aryl. Okay, alkyl halide, aryl halide. You may take haloalkane, haloarene. So the made to react with sodium metal means, of course, the reaction same. So in the presence of which is the solvent here? Of course, dry ether. For both Woods reaction, Fittig reaction and Woods Fittig reaction, dry ether is the reagent. And what is the product formed here? The benzene ring. Our groups are attached. Alkyl substituted benzene. Alkyl substituted benzene, and the byproduct is 2NaX. And here this is alkyl halide, aryl halide made to react with sodium metal in presence of a dry ether, that is said to be Woods Fittig reaction, and the product formed is alkyl substituted benzene. So if you take the example here, no need to write the, for 2 marks if they ask students, they'll simply ask write Woods reaction, Woods Fittig reaction. Sometimes they say explain. If they mention only right, this is enough. Okay, Woods reaction with an example. So example is enough. Explain, then only you need to explain in words. So you may know one alkyl halide and aryl halide reacts with sodium metal in presence of dry ether gives alkyl substituted benzene. This is the way to write the explanation. Means reactants have reacted with each other. So this is the condition in presence of what, at which temperature, whether the temperature is given or not. This is the condition followed by this products. So if here plus is there, you are going to use reacts with. In the reactant side, the plus charge, plus, it is tells about what? Plus sign reacts with. Alkyl halide reacts with sodium, further reacts with aryl halide. Here, in the product side, this positive sign indicates along with. That remember how to write the explanation. Okay. So next here, for this alkyl, I take methyl bromide plus 2Na plus okay. So students, here the products formed are the presence of the dry here to the benzene ring CH3 is attached. What is the name of this compound? This one? This is 2Na here. That's different. Okay, this one is alkyl. Which one is alkyl here? Methyl benzene. Okay, so here it is bromomethane. Here it is bromobenzene. Okay, let's have an explanation. And bromomethane and bromobenzene reacts with sodium metal in presence of a dry ether, forms methyl benzene along with sodium bromide. Remember students, in all the examples, Woods reaction, Fittig reaction, Woods Fittig reaction, I choose same type of halides. This is also Br, this is also Br. If it is Cl, this is also Cl. Why we are not going to use different halides? That may be a question arising here. So the thing is, these are the named reactions the scientists so always choose identical alkyl halides. If the alkyl halides are different, as I told you, the bromine, chlorine, iodine, they have different reactivity. So those reactivity order affects the reaction. That's why they prefer identical alkyl or aryl compounds in the reaction. Halogen atoms especially, not R group. Okay? Sometimes I said CH3Br means here also CH3Br I choose, not C2H5Br. So identical and you cannot take any different R group. R group and the halogen group must be same. That is why, because these scientists, by taking identical reactants only, they explain the reactions. Understood? So this is all about Woods reaction, fatigue reaction and Woods fatigue reaction. So the next one is Finkelstein and Schwarz reaction. Finkelstein reaction. Another one is Schwarz reaction. Both the reactions are halogen exchange reactions. So one is Finkelstein, another one is Schwarz. Okay, so this is the chemical property or preparation. Okay, by taking here the reagent you are going to use is NaR. Okay, in Finkelstein reaction, the reagent not NaI. Okay, so here the Schwarz reaction it is Ag here. Or you may take Hg2 here, both. Understood? These two are the example for halogen exchange reaction. Okay, what happens here? Listen. An alkyl compound, alkyl halides, or maybe aryl halides, any halides made to react with this NaI in the presence of acetone and heated. Means alkyl or aryl halides. Okay, made to react with sodium iodide are heated in presence of acetone. Okay, these two are heated in presence of acetone. Gives what? As I told you, this is a halogen exchange reaction. Here which is the halogen X, here which is the halogen I. Their exchange takes place. So here it is Ri plus Na. So this is the reaction that specifically used to prepare iodo, alkyl iodoalkanes or alkyl iodides. Okay, so this one is alkyl or aryl halides. This one is sodium iodide, and this one is alkyl or aryl iodide. If you take the example CH3Cl plus NaI in presence of acetone and heated. What is the product formed here? CH3I plus NaCl. So how can you say the explanation here? Methyl chloride or chloromethane heated with sodium iodide in presence of acetone. Then iodomethane is going to form. Okay, so this is chloromethane, this is iodomethane. You may take benzene ring instead of that. Benzene ring with Cl, Br plus NaI. What is the product? What is the product here? Benzene ring with iodobenzene plus NaBr. This is one type of halogen exchange reaction. Understand? So the next one, Schwarz reaction. So here also same Rx compound, but the here reagent used is what? AgF. There is no need to add any extra reagents here, like acetone or triether or any condition. Reaction condition is not necessary because here AgF is there. Here, except F, all the halides are there. As I told you, alkyl halides are compared to fluorine, fluorine, bromine, iodine. Fluorine is not stable. Fluorine, bromine, iodine is stable. Here we are using AgF. Even though the AgCl salt, AgBr, AgI salts are more stable than this fluorine. Understood? Means silver has more affinity towards chlorine, bromine, iodine rather than this fluorine. So easily the exchange reaction takes place. What happens here? Here this is the halogen, here this is the halogen. Exchange takes place means the reagent formed here is, product formed here is what? Rn plus AgX. This is specially used to prepare alkyl fluorides. This is specially, Finkelstein reaction is specially to prepare alkyl iodides. This is alkyl fluorides. Understood? So listen. If CH3Cl is there plus AgF is there, then what is the product found here? CH3 yeah, plus Ag. So students, how can you compare whether the reaction is taking place or not? Because this is going to precipitate. I hope you understand or you already observed in the salt analysis. If Cl atom is there, if you add AgNO3 solution, a white precipitate will form in the salt analysis laboratory. Second group acid radical chloride may be present. How to confirm? A salt solution, if HaNO3 is added, white precipitate is there. So in that, if AgCl is there, that is white precipitate. White PPT. If AgBr is there, yellow PPT. Okay? If AgI is there, violet PPT. AgCl is there, white. AgBr is there, yellow. AgI is there, violet. So from these colored precipitate, we can easily say which type of halogen is present in the respective compound. Here, after adding AgF, if we get yellow PPT, then what can we say? So this compound consists of bromide halogen. If it gets violet PPT, we can easily say it consists of iodide halogen. Understood? So this is Finkelstein reaction and Schwarz reaction, and both are halogen exchange reaction. Equation number what? 8. Sam Layers Sandmeyer's reaction. Okay, so in this Sandmeyer's reaction, so we are going to use diazonium salts. Understand? We are going to use diazonium salts. This is diazonium chloride. Why it is called as diazonium means N double bond N group is there. This group is called as azo. If N is there, that is azo. Two nitrogen atoms are there, diazo. Diazonium chloride especially. Okay. Diazonium chlorides. So they made to react with the presence of concentrated Cl. Okay. If we want Cl, we have to take Cu2 Cl2 here. If we want Br, we have to take Cu2 Br2 here. Only Cl and Br can be possible, not chloride, not iodide. Understood? Only chlorine and bromine are possible. Here if you want, you especially explain about the HALOALKANES and HALOARENEs. So this one is N. So then here it is Cl plus K2. This is the reaction. This reaction is called as Sandmeyer's reaction. Chlorobenzene. Okay? Understood? So if we want Br here, then what is the reaction condition? Here we have to take Cu2 Br and concentrated. Here Cl is there. Then here what we are going to take? HBr, hydrogen bromide. So then we will get bromo. So if means how can you say here? So listen students, here also Cl is there, here also Cl is there. But in the reactant side, here N2Cl you take, which is minus, this is here Cl is there, here Br is there. Then in the reaction mechanism, this Cl is eliminated. The Br present with Cu2 Br2 is going to attach here. That is different mechanism. Don't think here Cl is there, so Cl is here. This is not, so this is eliminated by HCl. Understood? So here what we are going to use the reagent that decides the product. If it is at the same step, how these diazonium salts are formed, that is diazotization. That we are going to discuss in the amines chapter. But still I will explain. Listen, initially the benzene made to react with NaNO2, nitrous acid, in presence of hormones like this, N2 plus Cl minus. What is the structure of this compound? Means N double bond N, Cl minus, this is plus. Understand? Okay. So this is the preparation. So complete this one is what? Diazotization test. So as we are studying the HALOALKANES and HALOARENEs, this step is enough. Okay, that is Sandmeyer's reaction. So no, I hope you can explain easily. When diazonium chlorides made to react with copper chloride in presence or heated in presence of copper chloride and concentrated itself, then chlorobenzene will form. Okay, next here when diazonium chlorides heated in presence of copper bromide and concentrated H forms bromobenzene along with the liberation of air. This is the explanation. That is Sandmeyer's reaction. Understood? So the next one is halogenation, sulfonation. So listen, halogenation, sulfonation, Friedel-Crafts alkylation, Friedel-Crafts acylation, and also sulfonation, nitration. So that all I'll explain in the same. Okay. At the time I'll explain with explanation. So initially, before that, you read which product is major, which product is minor. So to know that, we need to write the resonance structures. So halogen compounds means, so this is the benzene with the halogen. So halogen atoms consist of 6 electron pairs, you know that. If we want to write Cl like this, correct? Outermost 7 valence electrons are there. Here 2 are bonded, remaining are here. Understood? This is the first structure. What is this? Aride halide. So here what happens? These two lone pair electrons involved in the resonance. So when they shifted here, they form double bond, and here only this type of electron is left. So here, listen. Here, to this carbon atom, 1, 2, 3, 4, 5 bonds are there. For carbon, how many bonds are possible? Only 4. So these electron shifts here. Then here we will get minus charge. Why? Because listen, here one electron is belong to this carbon, another electron is belong to this carbon. Okay, so this electron, as I told you here, when the double bond is formed, then it gets the valency 5. So that's why this carbon shift electron here. Then here extra electron means that is minus charge. Next, later what happens? These electron shifts here and these electron shifts here. Same, the resonance happens. So here bond is there already. So due to the shifting of electrons, here bond will form. So due to the shifting of these electrons to this position, here minus charge will form. Here as it is double bond X. Okay. Next. Again these shifts here and these shifts here. Then the resonating structure becomes here minus, here the bond formation takes place, double bond X. Okay, so students, at the final, these again shifts here. So then this becomes unstable means these electron shifts here. Means here single bond X becomes 6 lone pair. Understand? This is the resonating structure. Means the lone pair of electrons and the halogens are involved in the resonance. When they are involved in the resonance, from at which position the negative charge means electron density is more? This one is R2. This is the bond where the X is attached. Okay, then these two are the ortho position, these two are the meta position, this one is the para position. Correct? If this is the functional group here, these two are ortho, these two are meta, this one is para. So at which position density is more means ortho, para, ortho. At ortho and para position, electron density is more. That means what? So if any incoming group is there, this halogen atom is present. So we are adding any extra incoming group. Okay, that incoming group directed to ortho position as well as para position. So these halogens are ortho-para directing groups. For NO2 we are saying it is a metal directing group, right? Similarly, these halogens are ortho-para directing group. Why? Because they create electron density more in the resonance at ortho and para position. So whatever the product formed here, that is ortho and para only. Understood? And remember, so here, which position is more? Means here, ortho is two positions are there, from here and here. There is two ortho position, only one para position. So always the major product is ortho product only. Here, these two are the ortho position, only one para position. Understood? So ortho product is ortho is the always the major product formed. Okay, so remember this. Based on this, we are going to conduct the following reactions. It is halogenation, sulfonation, nitration, anything. So here minus is there means. So which type of species is going to attach here? Plus. The species with the positive charge. What are those called as? Electrophiles. The species which are having affinity towards electron are called as electrophiles. Okay, so this is electrophilic substitution reaction. Understood? Okay. So listen. So in the halogenation, you may take chlorination, bromination. So here chlorination. For HALOALKANES and HALOARENES, chlorination of electrophilic substitution reaction of chlorobenzene. So students, we are going to use only chlorobenzene as the reactant here. Okay. Electrophilic substitution reaction of chlorobenzene. Here the reagent we are going to take is what? Only chlorobenzene. So first one is chlorination. Halogenation, it may be bromination, chlorination, iodination. The most famous is chlorination and bromination. Okay, so those are the halogens. So here benzene ring is there. Okay, to which, as I told you, this is the chlorobenzene, because we are taking chlorobenzene as the example for each and every reaction. Okay, so with respect to this, these two are the ortho position, these two are the meta, this one is the para. Chlorination takes place means addition of Cl2. Chlorination takes place means that is only addition of Cl2 in presence of FeCl3 or Fe as a catalyst. Fe or FeCl3 as a catalyst. Why we need catalyst? Because chlorine is a gas. You know, halogens are gases. That's why we need catalyst. Okay, so this is in 2 modes. Why? Later I'll say. Okay. So which type of products they will form? One is, this is Cl, ortho substituted. Another one is, which one? One is ortho means another one para substituted. Plus, there is also H is there, here is also H is there, so 2 HCl is removed. Understand? I won't write HCl here, okay, later I write. So this is ortho substituted and para substituted dichlorobenzene. Ortho dichlorobenzene, para dichlorobenzene. What is this? Chlorination. How can you say? So when the chlorobenzene undergoes chlorination in presence of iron as a catalyst or iron chloride as a catalyst, then they form a mixture of artho and para substituted dichlorobenzene. In that, this one is the major one. This one is the minor one. Major product, minor product. Understood? Okay. Next, second one is nitration. And remember here, so here H plus is there, Cl minus is there, correct? In this H plus Cl minus. Ma'am, here Cl is there, Cl is minus. How can, if here you write electrophilic substitution but you are adding Cl is here, how can you say Cl is always minus? It is wrong. This Cl is dissociated heterolytic cleavage bond. Heterolytic cleavage of the bond takes place. Means if they exactly break up the metal, they will form Cl dot, Cl dot. But they will not dissociate like that. So heterolytic bond cleavage means either two electrons are one side, one is Cl plus, another one is Cl minus. So this Cl minus combines with H plus, forms HCl. And here they form the minus charge. So Cl plus is going to attach here. That's why it is electrophile. Don't think halogens are always in minus charge. Minus charge means here they are not electrophiles, they are nucleophiles. That depends upon the resonance. Here depends upon what? Cleavage. Understood? So the next one is nitration. So nitration means always the mixture must be H2SO4 and HNO3 and both are concentrated here. Okay, so listen, how the nucleophile is going to form here. This H2SO4 initially dissociate as H plus and HSO4 minus. First step, this H plus combines with HNO3. Understood? How? Listen, HNO3 is written as N double bond O, OH plus H plus is going to react. How this OH is dissociated as like what? OH is always dissociated as negative or positive species? Negative, like OH minus means along with this. So OH minus and H plus forms H2O. Correct? So here it is minus, this will get what? Plus charge, that is NO2 plus. This is the electrophile generated in the nitrating mixture. This is the mechanism takes place. Initially this acid gives one proton. That proton is made to react with nitric acid and by the removal of water molecule they generate electrophile NO2. That they will not explain in any reactions in the NCERT. They won't give dissociation of these reagents or catalyst we are going to use. They simply give electrophilic substitution. If this is there, then nitro product will form. They didn't explain why nitro, why not sulfur. Understood? Okay. This is not necessary for you. Just I explain. So nitration means here chlorobenzene is there. Same, nitrating mixture means concentrated HNO3 in H2SO4. This is the nitrating mixture. What is the product formed? One is the Cl is common. This is the reagent. One is artho substituted nitrobenzene. Another one is para substituted. Among nitro and chloro, according to alphabetical order, which comes first? Chloro. So this is artho chloronitrobenzene. This is para chloronitrobenzene. Understood? So this one, for these, they won't ask any reaction. Like they won't ask any explanation. They'll just say chlorination of this, nitration of this, like that. So the third one is sulfonation. Okay? In this sulfonation, the reagent is concentrated H2SO4. How it is dissociated? Listen. H2SO4. This is written as S double bond O double bond O OH OH. Okay? So OH is dissociated as OH minus, and from here in all the case H is there. H plus and OH minus forms H2O. Always you know concentrated H2SO4 is a dehydrating agent. Water molecule removal takes place, but they won't say. So here if OH minus is liberated, then here plus will form. But it is SO3H. SO3H. This is going to attach in the place of argon carbon. Understood? That is sulfonation. Means, so you are going to take benzene ring here. That is chlorobenzene treated with concentrated H2SO4 undergoes sulfonation, forms which type of product? Ortho-substituted sulfonic acid plus para-substituted chloro-sulfonic acid. This is the here what we are going to see, only we need to check which one is the electrophile here. If we know the electrophile, the reaction is easy. One is argon, another one is carbon. Understood? So the next one is Riederkraft alkylation. Riederkraft alkylation. Okay. So what is this Riederkraft alkylation and also Riederkraft acylation? Here I take. So listen students, alkylation means your benzene ring is there, always alkyl halides, anything in presence of anhydrous aluminium chloride. This is acyl CH3COCl in presence of anhydrous aluminium chloride. These two are the reagents. In this, how can it dissociate CH3Cl? CH3 plus Cl minus, then plus species is going to attach. So here the benzene is there, here you are using CH3Cl in presence of anhydrous aluminium chloride. Then what is the product formed here? Here Cl, here it is CH3 plus another one is para substituted. Here it is Cl, here it is CH3. Okay, so now chloro and methyl, chloro comes first. So orthochloromethyl benzene, para-chloromethyl benzene. Or this is with the CH3 group that is called as toluene. Orthochlorotoluene, para-chlorotoluene. You may say means benzene ring with CH3 is called as toluene. This is orthochlorotoluene. This is para-chlorotoluene. Next, similarly here. So students here, which one is going to attach here? Listen, let me write this. CH3, C double bond O, Cl. C double bond O, Cl. How can this can be, sorry, how this is can be dissociated? CH3 C double bond O plus Cl minus. So this is going to attach. So that is CO, CH3, CO, CH3. Okay. So from all these, what you are going to observe? The electrophile, how it is generated. The one electrophile, if you know how it is generated, then always the product formed in this haloalkane and haloarene is the argon para, in that the major is argo substituted. And remember, always in every reaction, nitrogen mixture means this is only. Sulfur addition means only this is the reagent. In everything, remember that. Nitration means these two are the reagents. Sulfonation means this. Friedel-Crafts alkylation means only this. Acylation means only this. Remember the reagents. Understood? So this is all about electrophilic substitution reaction of chlorobenzene. In the tomorrow's class, we will done with the remaining reactions. Thank you.